My name is Dave Braig. I am a product manager at Cesium. I don't know if anybody here actually has heard of Cesium or worked with Cesium. Fair amount. Cool. I've been with Cesium for about 4 years now and worked a number of projects. So I originally was hired for smart construction activities. So with that, we did a partnership with Komatsu and now Earthcrane in developing construction tracking applications using our stack, mostly focused on earthworks, cut and fills, preparing the site for the vertical builds. And more recently, I'm product manager on our AEC team as well as our data curation teams here. So I just wanted to talk a little bit here about the tools that we have, some of these valuable tools for AECO processes, starting with our platform, our open platform, as well as our 3D tiles data streaming capabilities. And then all of those things together, coupled together to increase accessibility to your design data and the amazing work that you guys are doing with inside of these solutions. So I have a video here. I don't know if this will play. Yeah. So there's an introductory video about Cesium. You guys can check it out online. It would have saved me about 30 seconds of talking, but the high level is that we have a platform that basically converts your data into 3D tiles. 3D tiles is an open format for streaming that content. And then that content can be consumed by runtime engines or web applications. So Cesium.js, they could also be consumed by Unreal, Unity, and NVIDIA Omniverse. The underlying portion of that thing and what powers that whole platform is a format called 3D tiles. 3D tiles is an open standard for streaming massive heterogeneous 3D geospatial data and breaking down that content and making it accessible quickly and easily. It can also be used for design data and things like that, which I'll talk to a little bit here. I'm a visual learner, so I think 3D tiles itself, when we look at this globe, each one of these colored tiles is a unique tile. And in the scene here, we're seeing as we zoom into a particular location, only those tiles that are important to your view are being loaded into your scene. This is how we are allowed to stream this highly complex data versus having the data, design data, any large data sets locally, and then working with those on your machine directly. Same video here, but this time we're looking at wireframes, right? So we can see how the triangles for this particular site are being loaded into the view as we get closer and closer to our target area. This is helping maintain a high frame rate by reducing the number of triangles and the draw calls inside of these applications. This is really the key philosophy to 3D tiles, is reducing that and only showing the information that you need in the scene that you're working on right now. All this stuff is great, works great for 3D, for geospatial content, point clouds, models, surveys, photogrammetry, terrain, all of those things. And accuracy is key with all of these things, right? So space, geospatially located, accurate content, and understanding how your design could fit inside of that geospatial context. The cool part is that same concept of 3D tiles, breaking these complex things down into bite-sized chunks that you can stream, also works well for design data too. And I'll talk about this here in a few seconds. So the Cesium platform itself has a couple of different tiers. First, we start with your data, right? So your data could be survey data, it could be point cloud data, it could be design data, imagery. You bring that content into Cesium Ion. We transform that into 3D tiles. The tiling pipelines convert that into 3D tiles, which allows us efficient streaming these capabilities. You can also combine that with geospatial content, curated content. We have worldwide terrain data, worldwide building data. We also integrate with Google Photorealistic 3D tiles. You can bring that content in to provide context for your design data. And then we have all of our runtimes are free and open source. So we have a web application, Cesium.js, that allows you to consume that stuff. Developers, integrators can build solutions around that, integrating that inside their application. We also have plugins for Cesium for Unreal. We have one for NVIDIA for Omniverse, as well as Unity as well. So you can take all of this data, put it into a platform, stream it in this open format called 3D tiles, and then consume it freely inside of these open source clients. And what does that really mean? It really means the way that 3D tiles loads data, it results in greater performance of your applications. So again, it's only bringing the content that you need. It also means a little bit less manual effort for updating things. So I can convert this once, I can stream this out, and I can make this data a little bit more accessible and interoperable across a wider range of platforms quickly and easily. We can use the same data set. I can now make it accessible directly in the web. I can make it accessible in Unreal, in Unity, and I can do all those things at the same time. If I want to update them, if there's design changes, I only need to update that one centralized data once, and then stream that content out. It also makes for easier deployments. So if I'm building small applications that are taking my design data and trying to make them accessible to other stakeholders, I don't need to include all the data anymore. The data is hosted on the web or within inside of your own infrastructure. So my actual builds of these applications are a little bit smaller. It also means I can do faster updates. I don't need to worry about getting the data and moving the data around. I only have that data in one location. I can stream that content out. And then it also helps with data security. Again, because I'm not sharing my data, I'm locking it down, whether that's on our hosted solution or with inside of we have a self-hosted solution as well that works with inside of your environment. So it cuts down all of that cost as well too, and concerns around passing on the data. So all this stuff is great. Like how do we all this kind of help with inside of the design space? So there's really four main areas here. One is, we take your data. So that could be your BIM data, your design data, photogrammetry, your point cloud imagery. We take all that data, we can convert that into 3D tiles. So that's an open standard. There's no vendor lock-in. Anybody that consumes or any application that consumes 3D tiles can view this data. We can then incorporate global context with inside of that. So in this case here, we're looking at Google's photorealistic 3D tiles wrapped around a site location. And then we can view and analyze that with inside of a multiple different open source clients. So that first step, ingesting your data with Cesium allows you to upload your data so you can ingest multiple data formats, last data, imagery, terrain data, as well as we have pre-built integrations, not quite as many as Autodesk and the 280 or so that they've got there. But one of the ones is with Sketchfab here, where we can integrate a Sketchfab model directly into Cesium, turn it into 3D tiles, and I can incorporate that with inside of my scene. Cesium also provides custom APIs. So if you're into development, there's APIs available that allow you to build applications around this and consume this content and share content across the organization. The heart of this really of Ion is converting the data. So there's tiling pipelines that take all of these different data formats and turn it into 3D tiles, maintaining the data quality and precision of the source data, but then also compressing that data down to 60 to 98% of the original data source size, which allows us also to stream that data a lot more efficiently than the source data. We can then take our data and add some global 3D context. So spatially place your projects like space, put information around it so you don't have to go build out models. You don't have to collect the neighborhoods, the surrounding areas. You can visually see your sites inside of the geospatial content. So there's two main buckets of this. We have proprietary content that we make available through our platform. There's a world terrain database, which is a global 3D terrain database. Bathymetry, same thing, but undersea, OSM buildings or 3D building footprints. And we just recently did stuff if you're interested in lunar. There's Cesium Moon Terrain, and now we're looking at Mars as well to build out a complete terrain imagery data set for those locations. And then we have third-party data, so we integrate with Google Photorealistic 3D tiles, Bing Maps, and then we have partners like Vexcel and some others that generate more high-quality site-specific 3D models as well, too, that you can then use as geospatial context for your specific site locations. We got all of that information together. We've got our site information that's converted. We've got the geospatial context. Now, how can I start to do that? There's a bunch of different open source clients that are available to us. We've been doing this. It's been open source, I believe, I want to say since 2012. Cesium.js itself has a little over 10 million downloads of users that are using this web applications open source out there to consume this content and build applications around this. Or you can bring these into native clients. So we have plugins that are free and open source for Cesium for Unreal, NVIDIA Omniverse, as well as Unity, where you can bring that content into there. And again, this is all pointing back to the same location. You don't have to transform your data in any way once it's inside of 3D tiles. So really the value we've heard digital twins a couple of times this morning. We've heard interoperability, speed to access, all of that stuff is really accelerating the value of your projects and getting that information out and being able to share it. streamed across multiple devices depending upon how you want to communicate your projects. That could be AR, VR, desktop, or mobile. Again, because we're pushing it into Unreal, Omniverse, Unity, whatever those applications can do, that data can now use all of those capabilities. You can share the data across our siloed user groups. We've heard a lot about contractors, regulators, the general public, creating something that communicates the vision of a project to the general public, and getting feedback is one of the areas we've seen a lot of work and a lot of success with a lot of the AEC firms that we've worked with. We also have the concept of time, right? So my data is in one location. I can go back and I can look at previous versions of the data. I can integrate this data with IoT sensors so I get real-time information. And then I can just do future simulations as well. So I can what if scenarios. What does this look like? How is this going to impact? What does this building look like within inside of the space? How is it going to affect the skyline? How is it going to affect the shadows within inside of a particular area? Being able to communicate all of that as well. I mentioned that 3D tiles is great for all this geospatial context, and we started right now we have a tech preview program for basically for just taking design data, taking IFC data, or taking Revit models, directly exporting those to 3D tiles, and then consuming that content within inside of these applications as well. So I'd like to do live, but it's probably better that we're not. So this is just a simple Unreal-based application showing one of this is a snowed and sample data from Autodesk, converted from Revit directly into 3D tiles. All this content is streaming down to this application. It's not locally hosted. You have access to the materials, the features, the layers. You can do queries against that. You can drive symbolization based upon the metadata with inside of the features as well. You can turn them on, turn them off. In this case here, we're doing a simple sun study, which again is just taking advantage of the capabilities that are inside of Unreal. It could be Omniverse, it could be Unity as well. There's a similar application we built for JS through the web using that same source data. So we convert it once and pass it out, make it accessible across a bunch of different platforms. It's been proven across a bunch of different use cases, a lot around the visualization aspects of project design and project delivery. Just a couple of examples here, but we're always looking for more data, more examples, more collaborators to work with to try to improve our tools. One of the things that Cesium, like kind of at the heart of Cesium, is putting something out to our community users and then listening how they're using it and then adjusting our tools and responding to that and really driving forward with that. So together, I just wanted to wrap up here. I think the Cesium platform, 3D tiles, all those things together, providing valuable tools for a lot of the processes that we're seeing with inside of the AECO industry, increasing the accessibility to design data, 3D tiles for efficient streaming and making it accessible across multiple platforms, and then Cesium's openness, right? So the platform is open. You can sign up for free. You can use the clients for free. A lot of the data, the global context is for free. So it's a lot of there just to enable, get people to use that the data and start to adopt it for their use cases. I think with that, I'll stop. Yeah, that's it.